If you take almost any liquid in the universe, right, and you cool it down until it freezes, the molecules just pack more tightly together.
Yeah, they compress.
Exactly. It becomes denser, it gets heavier, and it sinks. But the water sitting in the glass next to you right now, it completely breaks the rules of physics.
It really does. It is a total anomaly.
Right, because when it freezes, it actually expands and it floats. And that single, like, rebellious chemical anomaly is basically the reason human history exists at all.
It is the ultimate paradox of nature. I mean, we are exploring a paper today for this deep dive, and it's titled Water and Civilization, or Suve Uygarlık by Mustafa Ergün.
And it is just a fascinating read.
It really is.
Yeah.
Because this text, it reframes our entire understanding of human development. We are looking at a 7 million year timeline where H2O is not just, a biological necessity, but the literal, invisible architect of human civilization.
Yeah, and the paper opens with this quote that I think perfectly captures that massive scale. It's from the 13th century thinker and poet Mevlana, who most people know as Rumi.
Oh, it's a beautiful quote.
It really is. He writes, "Think you are water, be a mercy, not a disaster. If you are water, do not flood people's fields, do not destroy their homes, fit into a glass so that you can enter veins."
Rumi beautifully identifies the dual nature of water there. And that is something Ergün meticulously traces through the entire geological and historical record.
Right.
Because water is our life giver.
Right.
It is the mercy that enters our veins and sustains our crops. But it is also our most terrifying catalyst for change.
Because of the floods and the droughts.
Exactly. The climatic shifts, the sudden droughts, the catastrophic floods. These are not just the backdrop against which human history happened. They are the actual engine that forced history to happen in the first place.
Okay, let's unpack this. Because to understand that engine, I think we have to look really closely at the physics of that ice cube floating in your glass.
The density anomaly.
Yeah. You mentioned earlier that water's density anomaly is a paradox. So let's trace the biological consequence of that. Because if water followed the standard rules of chemistry and solid ice sank, every ice age this planet has ever experienced would have been a massive mass extinction event for aquatic life.
Unquestionably. I mean, just picture a massive inland sea during a really harsh, prolonged winter.
Okay.
If the surface water froze and became denser like normal liquids, that sheet of ice would immediately plummet to the ocean floor.
Wow.
And that exposes the next layer of liquid water to the freezing air. So that layer freezes, becomes dense, and sinks too.
Oh, I see where this is going.
Right. The cycle just repeats until the entire body of water from the Mariana Trench to the shallowest lake freezes entirely solid from the bottom up.
Which means everything dies.
Everything. Every fish, every microorganism, every aquatic plant is just crushed in a solid block of ice.
So the fact that water molecules arrange themselves into this crystalline lattice that actually takes up more space, which makes ice about 9% less dense than liquid water, that means nature essentially builds its own thermal blanket.
Precisely. The ice forms on top, it floats, and it insulates the liquid water beneath it.
Protecting all the ecosystems just swimming around in the dark down there. It is like nature built a literal thermal blanket for aquatic ecosystems.
And that thermal blanket is the foundational prerequisite for continuous life on a planet that undergoes such severe cyclical climate fluctuations.
But Ergin's research goes way beyond just the biological necessity of water, right?
Oh, absolutely. The paper argues that water is actually embedded in the very first sounds human beings ever consciously constructed.
Which blew my mind. We are talking about the origins of language itself.
Yes, the mechanics of human vocalization presented here are just fascinating.
Because if you imagine an early human, right, someone without any complex vocabulary, making the path of least resistance sound, they just open their vocal tract, relax their jaw, and push air out from their lungs.
Right, requiring absolutely zero tongue manipulation.
And the sound you get is just air.
It is the purest, most biologically efficient vibration a human throat can produce.
And then to stop that sound, the quickest, most energy-efficient mechanical movement is simply to close your lips.
The bilabial stop.
Exactly. You get a B or a P sound. So you take the relaxed air, you close your lips, and the sound produced is AB.
And this is where it gets incredible. In ancient Turkic languages, the word for water is AB.
Wow.
And when we look at Sumerian, which is one of the earliest complex written languages we have on record, the word ABSU refers specifically to drinkable groundwater.
Wait, really? ABS.
Yes, so this suggests that language didn't evolve first for, complex abstract thought or even for coordinating a hunt.
So is it possible that language itself evolved first and foremost just so early humans could tell each other where the water was?
That is exactly what the text implies. The very first rudimentary phonetic building blocks were likely assigned to the most urgent survival metric.
Because if I am an early human, the absolutely most critical piece of data I can share with my family is the location of the water source.
Right, you need a sound for it that requires the absolute minimum caloric and cognitive effort, AB.
It grounds linguistics in pure evolutionary pragmatism. I love that. Before language is poetry, before it is law, it is literally just a survival beacon.
Exactly. From the molecular structure that insulates our oceans to the simplest syllables vibrating in a Paleolithic throat, water is the baseline.
So, having established what water is to us biologically and linguistically, we really need to understand how its physical distribution shaped early human migration.
And that distribution is entirely at the mercy of planetary mechanics.
Right, because the paper spends a lot of time on the Milankovitch cycles, which kind of serve as this cosmic metronome dictating the Earth's climate.
To really map the birth of civilization, you have to zoom way out into the solar system.
Mm.
I mean, the Earth does not trace a perfect circle around the sun.
Which I think we often forget.
We do. Nor does it spin on a perfectly stable axis. The gravitational pulls from the sun, the moon, and massive planets like Jupiter and Saturn, they actually cause our planet's orbit to flex and wobble over time.
It's a complex, overlapping rhythm. Like the shape of the Earth's orbit stretches from circular to slightly elliptical roughly every 100,000 to 400,000 years. That's the eccentricity cycle,
Yeah,
right?
exactly.
Then the angle of our axial tilt shifts every 41,000 years, and the axis itself wobbles like a spinning top that's losing momentum every 21,000 years.
And those shifting geometries determine exactly how much solar radiation hits the Earth's surface at any given latitude.
So they are basically the master switches for the planet's climate.
They are. Over the last 400,000 years, the alignment of those cycles has plunged the Earth into 4 major ice ages.
4 of them.
Yes. For 80% of recent geological time, the planet has been locked in a deep freeze.
Wait, 80%? That is wild.
It is. The relatively warm, stable climate we enjoy today is actually a brief interglacial anomaly.
Wow. So when we look at the last glacial maximum, which was around 20,000 years ago, the global map was completely unrecognizable to us today.
Utterly unrecognizable. Sea levels were 125 to 130 meters lower than they are today.
Because all the water was locked up in ice?
Exactly. Coastal shelves were massive dry plains. But the most critical factor for human development was the extreme compression of the climate zones.
The geographic squeeze.
Right. You have the northern hemisphere, roughly 45 degrees north latitude and above, just buried under ice sheets that are miles thick.
So just a completely uninhabitable frozen tundra up north.
Yes. And if we look south towards the equator, the situation was equally hostile, though for entirely different reasons.
How so?
Because millions of cubic miles of water were locked up in those northern ice sheets, the global oceans were much smaller and much colder.
Okay.
That meant a drastic reduction in evaporation.
And less evaporation means less atmospheric moisture, which means almost no rain.
Precisely. So the tropics during the last glacial maximum were not the lush green rainforests we picture today. They were characterized by severe desertification.
So you have an atmosphere down south that is incredibly dry and just choked with dust.
Humanity essentially found itself geographically trapped. The north is an impenetrable freezer. The deep south is a hyper-arid oven.
So where did they go?
The only viable, relatively temperate environment capable of sustaining hunter-gatherer populations was severely squeezed into a remarkably narrow belt.
Between the 35th and 40th parallels in the northern hemisphere.
Exactly.
Wait, so you're telling me that humanity needed to be absolutely miserable and squeezed into a tiny, freezing, arid strip of land just to get creative?
Well, yes. Harsh conditions breed innovation. But to answer why they stayed there, it is a matter of carrying capacity and geographical barriers.
Because my first thought is, if I'm a nomadic hunter-gatherer facing encroaching ice from the north, why wouldn't I just keep walking south?
Right, even if the equator is drier than normal, there have to be pockets of habitability. Right?
Yeah. Why stay trapped in this narrow, highly volatile squeeze zone where the winters are still brutal?
Because moving south meant crossing vast, rapidly expanding deserts with zero guarantee of finding a reliable water source.
Oh, that makes sense.
Hunter-gatherer bands rely on known seasonal migration routes. You cannot march a tribe of 50 people, including kids and the elderly, across 1,000 miles of new, uncharted desert on the faint hope that a hypothetical oasis exists near the equator.
That is a death sentence.
It is. The 35 to 40 degree belt, particularly around the inland basins of Eurasia, offered reliable, albeit challenging, river systems fed by mountain glacial melt. They stayed because it was the only zone that offered a mathematical probability of survival.
And staying in that challenging zone is the exact friction that sparks human advancement.
Yes, the paper brings in the historian Arnold J. Toynbee's concept of challenge and response, which is heavily influenced by Hegelian philosophy.
Right, Hegel's dialectic.
Exactly. Hegel proposed that progress only happens through a dialectic and a friction between opposing forces. You have a thesis, which encounters an antithesis, and the struggle between them creates a new synthesis.
So Toynbee applied this to human history and geography.
He did. The thesis is the human drive to survive. The antithesis is a highly volatile, punishing climate.
And the synthesis is civilization itself.
Precisely. The law of evolution, as discussed in the text, dictates that if an environment is too accommodating, there's absolutely no pressure to innovate.
Because why would you? If
Yeah.
you are in a microclimate where fruit grows year-round and weather is predictable, you simply exist.
Right. You don't need to invent complex agriculture, you don't need long-term grain storage, and you certainly don't need to develop a rigid social hierarchy to manage scarce resources.
The people trapped in that 35 to 40 degree latitude band didn't have the luxury of stasis.
No, they did not. They had fluctuating seasons, unpredictable river yields, scarce game.
They were forced to adapt their behavior radically just to survive to see the next spring. So civilization requires adapting to changing environments, not just existing in perfect ones.
Exactly. Civilization is not a luxury born of comfort. It is a highly demanding survival strategy forged in the crucible of a hostile environment.
Now, that slow, methodical adaptation to a tough environment makes sense over millennia, but the survival strategy of a geographically trapped population is entirely dependent on the environment remaining relatively stable in its hostility.
Yes.
What happens when the landscape doesn't just change slowly, but changes essentially overnight?
And this brings us to the Caspian Sea, the Turan Basin, and a catastrophic event that forced humanity to invent the very concept of the city.
Geographically, the Caspian and Turan regions form the world's largest inland closed basin, and it sits perfectly within that critical 35 to 40 degree latitude squeeze zone we just talked about.
Yes. And for thousands of years, hunter-gatherer populations thrived in the valleys of this basin, just adapting to the slow, steady rhythms of the Ice Age.
Then, around 15,000 years ago, the geological record indicates a sudden, massive disruption. According to the research cited in Ergün's text, a massive meteor struck the Arctic ice dam.
We really have to visualize the sheer scale of the water being held back by those northern ice sheets.
It's hard to even picture.
It is an unfathomable volume of glacial meltwater just pooled behind walls of solid ice. So when that meteor impacted, it shattered the structural integrity of the ice dam.
And the resulting event is known geologically as the Cavolinian transgression.
Right. The meltwater surged southward, seeking the lowest point of elevation, which of course was the Caspian Basin.
And the numbers recorded in the geological strata here are just terrifying. The water level in this massive inland basin shot up from 150 meters below sea level to 50 meters above sea level.
That is a 200-meter vertical rise in the water table.
A 600-foot wall of water, just inundating a landscape where people had lived for generations.
It completely shatters the old philosophical rule, natura non facit saltus.
Nature makes no leaps.
Exactly. We expect geology and evolution to move at a pace so slow it is invisible to a single human lifespan. But here, nature leaped with devastating violence.
Here's where it gets really interesting. Imagine waking up and your local valley is suddenly a sea. You don't have time to invent city planning slowly over generations.
The panic would have been absolute.
Yeah,
And this is the exact mechanism that triggers urbanization.
because you cannot outrun a flood of this magnitude slowly.
No, you cannot sit around a campfire and organically develop a philosophical consensus on civic duty over 3 generations. If you want to survive the rising water, you need to dig a diversion trench, and you need to do it immediately.
You grab a shovel and you grab 500 of your neighbors.
And you begin to dig. Suddenly, out of sheer terror and necessity, you've created a complex social hierarchy.
Because someone has to do the physical digging.
Right. And someone else has to stop digging to go hunt and gather food to feed the diggers.
And someone with spatial awareness has to stand on a hill and direct where the trench needs to go so it actually works.
Exactly. You have just invented the division of labor, civic engineering, and hierarchical leadership in a single afternoon. simply to avoid drowning.
And the linguistic footprint of this panic is still visible today, which is amazing. The source text traces the evolution of the word for urban back to this exact region and event.
It starts with the ancient Turkic root word, or
And in its earliest usage, or literally translates to a ditch or a trench, right?
specifically a trench dug into the earth to protect a community from rising waters or later from enemies.
So over time, as the immediate floodwaters stabilized, that protective trench became a permanent moat.
Yes, the moat surrounded the settlement, and eventually the word for the protective ditch became synonymous with the settlement itself.
From meaning a desperate ditch in the dirt, we derive the linguistic roots for modern words: organization, order, urban.
Yes.
And it forms the names of the most ancient foundational cities in human history. Uruk, Urfa.
The very concept of living in a dense, organized settlement is linguistically tied to the trauma of a megaflood. It really forces us to reevaluate the genesis of the city.
We do often romanticize early cities as these grand monuments to human intellect or bustling hubs of trade.
But they were not. They were life rafts. They were defensive certifications against a hyperviolent hydrology.
And the psychological impact of the Kavlinian transgression was so profound that it became encoded into the spiritual DNA of humanity.
Oh, absolutely.
Because when you have a 200-meter rise in water that wipes out entire valleys and forces the survivors to build these fortified urs, that trauma gets passed down through oral tradition. It likely became the geographical and historical bedrock for the global flood myths, like the story of New Tufana or Noah's Ark.
The mythology of a civilization-ending flood is nearly universal across early cultures, precisely because, for the people in the Tehran Basin, it was a literal historical reality. They banded together, they dug their trenches, and they survived the rising waters.
But the environmental whiplash of this region wasn't over. They survived the megaflood, but the planet operates on those cycles we talked about. After the catastrophic inundation comes the slow, agonizing retreat of the water.
Yes. Following the Kavlinian transgression, the massive inland sea slowly began to evaporate.
Over the next several thousand years, the water level in the Caspian Basin dropped from its peak of plus 50 meters all the way down to today's level of around minus 28 meters below sea level.
And that staggering loss of surface water fundamentally altered the landscape again. A region that had been transformed into a lush, water-rich environment by the flood was slowly baked into some of the most unforgiving terrain on Earth.
The retreating waters left behind massive deposits of sediment and sand, which the wind eventually shaped into the Karakum and Kizilkum deserts.
And this creates a completely different evolutionary pressure. A sudden flood forces immediate, panicked reaction, but a slow-moving, multi-generational drought. That forces a society to engineer a permanent, highly calculated solution.
Because the population of the Tehran region had now grown accustomed to settled, organized urban life, they had populations way too large to simply revert to nomadic hunting.
Exactly. When the surface water vanishes, how do you sustain a city? You cannot rely on rain, and the surface rivers are evaporating long before they reach your crops.
So the only direction left to go is underground.
Yes.
Which leads to the creation of what I think are the most underappreciated engineering marvels in human history, the Karez.
The Karez, which are also known as Qanats in other regions, are subterranean aqueducts. And the text highlights the Uyghur-Turfan Karez system in Xinjiang.
The sheer scale of the mathematics and labor involved there is just mind-boggling.
It is difficult to comprehend. The length of this specific underground network is 5,000 kilometers.
5,000! Think about your daily commute for a second. Now imagine a hand-dug, perfectly graded underground tunnel beneath that entire route. And these weren't just shallow trenches covered with wood.
No, some of these tunnels were dug 110 meters over 350 feet straight down beneath the desert surface.
Built 2,500 years ago.
The environmental logic behind the Karez is brilliant. The water source is reliable. It's the massive melting glaciers of the Tian Shan Mountains.
But to get that glacial melt to the fertile, arable land of the Turfan Oasis, the water has to cross a scorching desert plain where surface temperatures routinely hit 40 degrees Celsius.
Right. And if you try to run that water through a traditional surface canal, the sun and the dry desert air will evaporate the entire flow before it travels even 5 miles.
So they buried the river.
They did. But the engineering required to do this in the dark, using primitive tools, is staggering. A Karez operates entirely on gravity.
There are no mechanical pumps.
None. To move water across dozens of kilometers underground, the tunnel must maintain a microscopic, continuous downward slope.
How does a society even begin to calculate a perfectly sloped 60-kilometer tunnel in the dark? Because if they get the math wrong by even a fraction of a degree, the whole system fails, right?
Oh, completely fails. Because if the downward slope is too steep, the water flows too quickly. Fast-moving water creates friction and turbulence, which scours the dirt walls of the tunnel.
And then the walls collapse.
Exactly. Within a few months, the erosion causes the tunnel roof to cave in, destroying the entire aqueduct.
But if the slope is too shallow,
Then the water loses momentum and stagnates. Silt builds up, the flow stops, and the oasis starves.
so they needed perfection. How did they achieve that 2,500 years ago?
They utilized an incredible mastery of practical geometry and hydrology. The construction actually starts at the destination, the oasis, and works backward, uphill, toward the mountain aquifer.
That makes sense.
The diggers excavate vertical access shafts every 20 to 35 meters. These shafts act as ventilation to keep the diggers from suffocating, and they serve as buckets to haul out the excavated earth.
But the alignment is the true genius here. They used the stars to map a perfectly straight line across the surface of the desert. Then, they dropped weighted plumb bobs down those vertical shafts to transfer that exact celestial alignment 300 feet underground.
And to maintain the microscopic slope, they likely used simple, highly effective water levels.
Like a modern carpenter's level, but just with water.
Exactly. A carved wooden trough filled with water.
Right.
If the water crests over the front edge of the trough by just a millimeter, you have established your microscopic downward gradient.
So you dig a few feet, advance the wooden trough, measure the spill, and keep digging.
It is a phenomenal achievement in civic planning. Digging a carrés was incredibly dangerous work, highly prone to cave-ins and suffocation.
It required a specialized workforce.
This wasn't casual labor. This
Yeah.
was a highly respected, highly compensated profession with structural engineering knowledge passed down through generations.
It proves that the civilizations operating in this harsh inland Tehran region were incredibly advanced long before Western historians traditionally give them credit. They were executing advanced physics and societal organization millennia before the Romans built their surface aqueducts.
They were. And the carrés systems allowed large populations to thrive in the desert for centuries. But even the most brilliant engineering cannot hold off global climate cycles indefinitely.
No.
As we follow the timeline in Ergün's paper, roughly 5,000 to 6,000 years ago, the planet experienced a phase of rapid global warming.
Which shifts the map entirely once again. We have to look at the geography known as the roof of the world. The Tibet Plateau, the Pamir Mountains, and the Tian Shan, which translates to the God Mountains.
These high-altitude plateaus are essentially the water towers of Asia. They hold the world's largest non-polar glaciers.
And those glaciers feed massive inland river systems like the Sehun or Amu Darya and the Sehun or Sur Darya.
Right. When that phase of rapid global warming hits, the immediate effect is a massive surge in meltwater. But eventually, the glacial ice pack shrinks dramatically.
The steady, reliable flow of water into the inland basins begins to dry up. The Tehran plains undergo severe total desertification. Even the deep mountain aquifers feeding the Karez systems begin to fail.
The inland environment becomes fundamentally hostile to large-scale urban life. But that melting ice didn't just vanish from the Earth, it was displaced.
Because as the massive glaciers of the roof of the world melted, billions of gallons of water flowed outward, eventually reaching the oceans. Global sea levels rose significantly.
And when you have rising sea levels meeting the sediment carried down by massive, slow-moving coastal rivers, you get the creation of the great river deltas.
This convergence of desertifying inland plains and newly forming fertile coastal deltas forces a major historical paradigm shift in how we view the timeline of human civilization.
It does. This is the part of the paper that completely rewrites the standard history textbook.
Right. Because in grade school, we are taught that the cradles of civilization emerged simultaneously and organically in specific coastal or river valley locations.
Yeah.
We are taught that complex human society began with the Egyptians on the Nile, the Sumerians in Mesopotamia between the Tigris and Euphrates, and the Harappans in the Indus Valley.
Standard historiography treats those locations as phase one of human advancement. But Ergün's synthesis of the climate data argues that this is entirely backward.
So what does this all mean?
It means those famous delta civilizations were actually formed later. They were not the inventors of civilization, they were the beneficiaries of it.
The ancient Egyptians and Sumerians we learn about weren't phase one of human civilization. They were the climate refugees of phase one.
Exactly. They were settled by people migrating away from the dying inland seas of the Caspian and the Aral and the drying mountain slopes of the Turan Basin.
They had already spent thousands of years trapped in the geographic squeeze zone. They had survived the Kalinian megaflood. They had invented the concept of the fortified
They had spent centuries mapping the stars, developing complex mathematics, and organizing mass labor forces to dig 5,000-kilometer Karee tunnels.
So when the inland water ran out, they didn't just wander aimlessly into the desert. They packed up all of that hard-won generational knowledge, their agriculture, their architectural math, their hierarchical civic structures, and they relocated to the newly formed deltas.
The deltas were the geographic prize. Once they arrived at the Nile or the Euphrates, the environment was vastly more forgiving than the Turan Basin.
They didn't have to invent a civilization from scratch. They simply unpacked the civilization they had already built and applied their advanced engineering to a landscape that was much easier to manipulate.
It reorients the entire map of human progress. The monumental architecture of Egypt and Sumer wasn't a sudden burst of isolated genius. It was the culmination of thousands of years of survival engineering forged in the harsh, arid steppes of Central Asia.
That is just incredible to think about. And the evidence for this massive migration of people and ideas isn't just archaeological or climatic, right? It is embedded deeply in the linguistic record.
Oh, heavily. Water didn't just move people, it moved ideas, languages, and future global power dynamics.
The paper points out the structural similarities between Sumerian, the language of Mesopotamia, and early Turkic languages.
Yes, Sumerian is often classified by linguists as an isolate, meaning a language with no known relatives. But it is an agglutinative language.
An agglutination is a specific morphological structure. Instead of having separate prepositions or constantly changing the root word to indicate tense or possession, an agglutinative language stacks suffixes onto a stable root word, like building blocks.
Exactly. For example, in Turkish, ev is house, evler is houses, evlerim is my houses, evlerim day is in my houses. You just keep adding distinct phonetic blocks.
And Sumerian uses this exact same grammatical architecture. Furthermore, the text notes that researchers have identified over 400 shared vocabulary words between ancient Sumerian and early Turkic languages.
You do not get 400 shared vocabulary words and an identical grammatical structure by coincidence. It strongly implies a shared geographical origin point in the inland basins before the great climate migration outward to the deltas.
And there are two specific conceptual words detailed in the text that I think perfectly capture the psychology of this ancient migrating culture: Hazar and Sefer.
The dichotomy of these two words is deeply revealing. Hazar translates to the state of being settled, at peace. It's heavily associated with engaging in agriculture around a reliable water source.
It is the root from which we get the name for the Caspian Sea, the Hazar Sea.
It is the ultimate goal. You want to be in a state of Hazar. But when the water dries up, you are forced into the opposite state.
Sefer. And Sefer means to be in motion, to be traveling, migrating,
Good.
and it is intrinsically linked to a state of conflict or war.
Because if your water source fails and you have to move your entire society to a new river valley, there is a very high probability that someone else is already living there. Migration invariably leads to resource conflict.
You are either settled where there is water or you are moving to find it, fighting for the right to drink. And this constant cycle of settling and moving across the vast expanses of Central Asia created a massive network of human interaction. The historian Arnold J. Toynbee provides a brilliant metaphor for this landscape.
He really does. Toynbee rejected the idea that the great dry steppe of Central Asia was a barren, isolating barrier. He argued that we should view the dry steppe as an inland sea.
It is a perfect visualization. If you think about an ocean, it is hostile and empty, but it connects everything on its shores.
Exactly. Toynbee pointed out that for human interaction and the transfer of technology, the flat, dry steppe actually had a high conductivity for human interaction, higher than the physical ocean, long before the invention of deep water sailing.
He described it beautifully, saying that on this vast dry ocean, horses were the galleys, camels were the galleons, and the isolated oasis towns scattered across the desert were the ports of call.
And the Silk Road is the most famous iteration of this network. But Ergün's text emphasizes that calling it the Silk Road diminishes its true function.
Because it wasn't just for silk.
No, not at all. It was not just a trade route for luxury textiles flowing to Rome. It was a massive, high-speed corridor for cultural, linguistic, and technological exchange.
The steppe was basically the world's first broadband network. just operating on horsepower instead of fiber optics.
I love that analogy. It was the ancient world's primary conduit for innovation. The metallurgical breakthroughs originating in the Altai region, learning how to smelt bronze and eventually iron, did not stay isolated.
Right.
The domestication of the horse, which completely revolutionized human travel and warfare, spread rapidly across this network. Advanced agricultural techniques and Carie's engineering knowledge flowed from oasis to oasis.
Every technological leap, every phonetic shift, every new way to manipulate water or earth traveled across this dry sea, connecting the eastern and western hemispheres in a continuous loop of shared knowledge. And all of it was driven by the baseline search for water.
Which brings Ergun's synthesis to a very stark, very modern conclusion. We have spent this deep dive looking at how the presence, absence, and management of water literally built the infrastructure of human civilization.
But in the modern era, we seem to have suffered from a sort of historical amnesia about this.
We really have, because for the last 2 centuries, global geopolitics has been obsessed with a different resource. The 19th, 20th, and 21st centuries have been almost entirely dictated by the extraction and control of energy. First coal, and then oil.
The carbon era.
Right. We have built global empires, fought world wars, and structured our entire planetary economy around fossil fuels.
Yeah.
But history is fundamentally a cycle of resource adaptation.
And as we move further into the 21st century, the paper concludes that while the last 200 years have been dominated by energy, the future will be entirely dictated by water management.
The paper implies a terrifying but inevitable reversion to the mean. The future of global geopolitics will not be determined by who controls the oil fields. The carbon era is a historical blip.
The geopolitical power dynamics of tomorrow will return to the original currency of human civilization.
Water. It will be entirely dictated by hydrological management. The nations that will wield the most influence will be those that control the headwaters of major rivers.
The technology of the future will not be about extracting oil, but perfecting mass desalination.
Exactly. As the glaciers melt again, governments will rise and fall based on their ability to manage the flooding of massive coastal megacities and their ability to sustain agriculture in rapidly expanding desertification zones.
It is a sobering reality check. Let's just take a breath and zoom out to look at the massive journey we've just covered in Ergun's text.
It is a huge timeline.
It really is. We started with the physical paradox of a simple molecule that expands when it freezes, providing a thermal blanket that allowed aquatic life to survive the ice ages.
We looked at the mechanics of the human throat, pushing air out to form the sound AB, the simplest phonetic beacon pointing to the most vital resource.
We traced how the Milankovitch cycles squeezed humanity into a narrow, highly volatile latitudinal band, forcing them into a Hegelian crucible where the only way to survive was to innovate.
We witnessed the Kalinian transgression, a 200-meter wall of glacial meltwater that terrified a hunter-gatherer population so profoundly they immediately invented the division of labor, digging trenches that eventually evolved into the very concept of the fortified or city.
We explored the subsequent millennia of drought, where that same population used celestial alignments and water levels to dig 5,000-kilometer networks of Carie's tunnels 300 feet below the desert floor.
And finally, we watched as global warming melted the high-altitude glaciers, turning the inland seas to dust and driving these master engineers outward as climate refugees to settle the great deltas of the Nile and the Euphrates, bringing the architectural and linguistic blueprints of civilization with them.
Water is the ultimate, unforgiving architect of everything we are.
And looking at that sweeping timeline forces a lingering, deeply provocative thought to leave you with, mulling over the source text.
What's that?
Well, the text proves that humanity's very first massive leap into what we call civilization, the sudden creation of complex urban organization, division of labor, and hierarchical engineering, was triggered specifically by a sudden, catastrophic change in water levels and the sudden melting of polar ice.
Which is exactly the environmental scenario we are facing right now.
Yes. The planetary metronome is shifting again. The ice is melting, the sea levels are rising, and the inland aquifers are drying up.
Wow.
If a 200-meter flood 15,000 years ago forced hunter-gatherers to invent the concept of the city just to survive, what incredible, currently unimaginable evolutionary or societal leap will our current era of rapid climate change and rising sea levels force us to make next?
When the coastal megacities are inundated and the equator becomes too hot for agriculture, where do we migrate? Will our cities of the future go underground again, like a massive modern Caries? Or will human society have to adapt to live permanently on the oceans themselves?
It is the ultimate question. The environment is about to leap again. We are entering a new cycle of challenge and response.
And the waters are rising. Thank you for joining us on this deep dive. Stay curious, keep asking questions, and the next time you pour a glass of water, remember the 7 million years of history swirling around inside it. We will see you next time.